Hey everyone, welcome back with a new lecture with how to calculate measurement uncertainty for microbiological measurements. In the previous lecture, I have explained artificial contamination or artificial inoculation by getting a pure culture which contain the target organism and there is no other interfering organisms in this culture. And we will use this culture to prepare the spiking solution that will be inoculated to the initial suspensions. And now also we will have control samples. Control samples or negative controls that will be used to ensure that there is no contamination in the analysis. So you should prepare control samples blank that doesn't contain the target organism, which don't contain the target organism, to serve as a negative controls which doesn't contain the target organism, to verify that the microorganism growth is due to the artificial inoculation only, not due to the contamination. And this sample, negative control or control sample, is very important to be prepared with every sequence after verification. When you will prepare quality control procedure, you shall add this sample with every sequence to ensure that there is no contamination during the process from the beginning till the end. And also we have this sample in chemical analysis, blank sample. Blank sample which doesn't contain the target analytes shall be run with every sequence to ensure that there is no contamination. And if there is any contamination during the process, that will be subtracted from every positive sample and also from the spike sample or whatever sample will have a result during this sequence. Then incubation. You should place the inoculated and control samples in the incubator, which is set at the required temperature and the conditions required for the growth of microorganisms. And these inoculated and control samples shall be labeled. Label each sample with the relevant information, including the type and the quantity of microorganism and date of inoculation and any other relevant details. So you already prepared the inoculated or spiked samples and control samples and kept them in the incubator, which set at the required temperature and whatever conditions required for growth of microorganisms. Then during the repetition, you should maximize the variation between repeated measurements. Maximize the variations between repeated measurements. You should have different variations during your analysis. You should apply many variations in all critical factors, all relevant sources of uncertainties that I have mentioned before during the preparation, including batches of culture media. You have only one brand of media, you can use different batches of this media. Reagents, you can have different reagents from different companies, or if you use the same company, in this case you can use different bottles or different batches. And membrane filter, same, vortex or other mixer, pH meter. Incubators, if you have different incubators, use all of them. Time of analysis also, you will make repetition on the same day by different analysis, and after that you will make repetition in other days, so you have a long time scale for reproducibility. And test portions. Test portions should be analyzed by different technicians, not only one technician. As I explained before, that all test portions shall be analyzed by all analysts inside the lab, and this is the best way during measurement uncertainty estimation, because operators change is the highest critical factor that will affect the result, is a big source of uncertainty. So the variation between different analysts will give you real work or real result for the measurement uncertainty at the end. And also, as you know, that microorganisms are living organisms, so the results will be changed very fast between repeated measurements, between replicate analysis. So from precautions that you should take during repetition, that measurement repetitions should be done within a short period of time on a single day. When you will run replicate analysis on a single day, you should make them or analyze them within a short period of time, and this is opposite to chemical analysis, because if you make replicate analysis even not within a short period of time, you can get the same result because it's fixed or stable, not like microorganisms which are living organisms, as the contamination of the food sample is rarely stable in food chain microbiology, except only in chemical analysis. There are some compounds which can be degraded quickly by temperature or by light, so in this case also you should take your precautions. And also in some cases with some matrices for some methods, you will find that contamination levels shown to be stable on a single day. When you will run replicate analysis on a single day, even within a short period of time or long period of time, you will find that contamination levels shown to be stable. In this case, better repetition can be performed in more than one day if contamination levels shown to be stable. And now calculations. Acceptable results. For colony count techniques, ensure that sufficiently large number of counted colonies can be used for calculations, and exclude all results less than 30 counted colonies, and also whatever above the maximum number per plate, which is in most cases, as mentioned in this standard, 300 CFU per plate, or lower as specified in the specific standard. So any result less than 30 count colonies or higher than 300 CFU per plate, that should be excluded in colony count techniques. But for methods including partial confirmation, any results for which less than half of the colonies tested were confirmed should be excluded. So number of colonies less, if was were less than half of the colonies tested, number of positive samples divided by 2, in this case these should be excluded. And for most probable number based methods, any results, also measurement results less than 5 positive test results should be excluded from the calculation of standard deviation of reproducibility. And relating to calculations that I have explained in the previous lecture, also you should know the equation for the intra-lab reproducibility, how to calculate intra-lab reproducibility. As I explained before, that you will get from each test sample 2 test portions, at least 2 test portions from each test sample for at least 10 samples. Then you will get result for each test portion. These results should be transformed to the log transformed data, log 10 CFU per gram or ml. So transform the results of test portions into log 10 CFU per gram or ml for at least 10 samples, n equal to 10 number of samples. Each one will be analyzed in duplicate as I explained before, so 2 values will be received for each lab sample, and these values will be like this: 1 IA and 1 IB. And the equation for intra-lab reproducibility standard deviation will be SIR, standard deviation for intra-lab reproducibility, equal to square root of 1 divided by 2n, number of samples, summation, the index of sample, if you analyze one sample up to 10 samples or more than 10 samples, from I equal to 1 sample up to n, which is higher than or equal to 10 samples of 1 IA, the result for first sample, first test portion, minus 1 IB squared. And these results will be log transformed data, not the result that you will get, not colonies counted, but you will transform these colonies counted from CFU per gram or ml to log 10 CFU per gram or ml. And to clarify what we have explained till now in calculation of standard deviation of intra-lab reproducibility, at the beginning 10 samples will be fortified or inoculated with the target organism by a specific volume determined before, as I explained in the lecture of artificial contamination or artificial inoculation. Each sample should be analyzed by 2 different analysts or more, according to a number of microbiologists you have in the lab. Maybe all of them can analyze the sample in test portions. Each one will prepare 2 test portions, and he will get the results for each one of each test portion. And each analyst will analyze the sample in duplicate to get 2 values for each sample. Count the colonies and then transform the data to log 10 CFU per gram or ml. Then collect the results for each test portions. For each sample you have 2 test portions, and you will calculate the average for each sample. Then after that, if test portions of each samples, and you will see this when we will calculate using Excel sheet, if the test portions of each sample analyzed in duplicates, so for each analyst will have 2 test portions, and each test portions will be analyzed in duplicate, so he will have 4 results. So you will calculate the summation of colonies counted, summation or total number of colonies counted, and that will be by summation of each 2 values. For each test portion you will have 2 values will be you will take the summation of these 2 values and summation of other test portion 2 values, then that will be the total number of colonies count. Then you will take the log 10 for this number of colonies, total number of colonies count, then the average between both of them, both test portions, and then you will calculate the difference for each result from the average, that related to the effect of matrix and also distribution, matrix uncertainty and distributional uncertainty, the difference for each result from the mean. Then squared the difference as you found in the equation. And after that also there are many other calculations after this calculations to get at the end the combined and then expanded uncertainty, and that will be explained in details but step by step. And at the end of this lecture we have 2 notes. And first one, that standard deviation of intralab reproducibility, as I explained before, already include matrix and the distributional uncertainty, so there is no need to calculate them again because that will overestimate the uncertainty. But in the next lecture inshallah I will explain matrix and then distributional uncertainty and how to calculate. And another note, that samples from interlab PT proficiency test, interlab, because it's, as I explained before, it's not on the same lab but between different laboratories. Proficiency test will be distributed to many laboratories, so this is inter-lab reproducibility. So BT samples in this case can be used also to calculate standard deviation of reproducibility inside the lab. You will prepare also 2 test portions for each analyst. Each analyst will prepare 2 test portions and they will get 2 values. Then you can use this for calculation. But if there is a difference, if you found difference between the PT sample and the real sample of the same type, of the same matrix, in this case better to use the real sample or natural sample, because matrix effect will be included in the real sample. Matrix effect will be included in the real sample that you analyze. You always analyze inside the lab. Matrix and distributional uncertainty will be included, so it's better to use the real sample. Thank you and see you in the next lecture.